Yeah, hi, is this Johann Sebastian Jorgensen? It's not? Sorry to bother you, ma'am. I'm sorry. All right, we'll see you later. Bye. Click. Okay, let's do some math. We're going to start off by introducing, you've probably seen this before, um, the tools for today. Now, when solving equations, you really it's like untangling a knot. We have this knot and we're trying to get to the truth. And the way that our tools for untangling are called mathematical inverses. Probably could have just said inverses as we are in a math class. They're the tools we use that help us to kind of get things undone. And they're operations. The opposite plus is minus. The opposite of times is divide. And it turns out in this class, these are the main two pairs that we're going to use of inverse operations. But there are actually many, many, many more, okay? So it's all about finding the unknown, right? Each of these equations is asking a question. And this question is, what number times negative 4.7 is 48? That's a question. And so you could go to your calculator and do 4.7 times this, or negative 4.7 times this, or negative 4.7, and just keep trying until you get close to 48. Or you can know that, hey, I'm going to use inverse operations. I'm taking W and I'm going to I'm currently multiplying it by negative 4.7. I want to undo multiplication. Well, where do we look? The opposite side of the chart. So we use this. We also need to know that if these two things are equal, that if I treat both sides equally, both sides should remain equal. So as long as you do something to one side, you must do it to the other side. So what we're going to do is we're going to undo multiplication. Okay, inverse operations undo each other. We're going to undo multiplication with division. I'm going to divide both sides of the equation by negative 4.7. All right. We have a positive divided by a negative. And so W is currently on the right side. W is approximately equal to negative 10.2. Okay? Pretty slick. Pretty slick, if you ask me. Let's see an easier one. Well, we're trying to find y. 7 plus what number is 5? 7 plus what number is 5? Not sure. So we got to get y by itself, which means we're going to undo the operation that's happening to it. The operation that's happening to y is we are adding 7. I apologize. There is a tap dancing group staying at our house. They just happen to be right above me. So they're going to be heading back to Ireland within the week. So I'll just look forward to that. Okay. 7 minus 7 is 0. 5 minus 2 is, 5 minus 7 is negative 2. So that gives us our answer of y equals negative 2. This is the number that makes the equation true, okay? Let's take a look at these other ones. We're getting warmed up. Now, all of these problems so far, let's move our inverses. They all happen in one step. There's one knot that we have to untie to get to the rope, okay? So right here, what operation is happening to our variable? We are dividing by 3.4. So to undo division by 3.4, I'm going to multiply both sides by 3.4. Which means I have to do 8 times 3.4, okay? When you take a number and you multiply it by 3.4 and then you divide it by 3.4, you get the number you started with, which was x. 8 times 3.4 is something. It is 8 times 3, 24, plus 0.4, 27.2. Hooray! And there was much rejoicing. 27.2 is our solution. So if I go back up to my equation and I do 27.2 divided by 3.4, I will get 8. Super. Okay. Solving for x. What operation is happening next? We're subtracting. We are subtracting 1/3. So we're going to add 1/3 to both sides. Plus 1/3 plus 1/3. Forget I did that sideways slashy thing. Least common multiple of 7 and 3 is 21. So to find our common denominator, we'll do -2 over, sorry. Yeah, well, I'm gonna rewrite it first. -2 over 7 plus 1/3. Common denominator is 21. So this is negative over 21 plus something over 21. We gotta write equivalent fractions. 7 times 3 is 21. So we're gonna multiply the top by 3 to get 6. 3 times 7, so we'll put a 7 there, and this is really -6 plus 7, which means our answer is 1 over 21. Super. These are all one-step equations. Some of them have fractions. But now, ladies and gentlemen, we are going to do two-step equations. Yeah, it's really unfortunate that that tap dancing group is here today during my recording. That's okay. So one thing that I think we math teachers are guilty of is we typically go to the easiest way to teach you how to do something, and it's not always the easiest way. It's the easiest way most of the time, but sometimes there are other ways that make sense, or make sense to some people more so than others. So what I'm going to do today is I'm going to approach two-step equations in maybe a different way than previous teachers have in the past for you. Okay, we're going to do things multiple different ways. I'm going to do each problem twice so you can see the different ways to approach each problem. Here's our first example. If we want to solve this, typically what you do is you look at the order of operations that basically you get rid of what you can. But if you look at order of operations, right? If I were to plug a number in, if I were to take a guess at the solution for x, let's say I plug the number 10 in for x. If I plug in 10, what's the first operation that would happen? Well, it would be times 2. We do 10 times 2 is 20, minus 8 is 12, and that's not equal to 14, so 10 is not a solution. But the order that I did there was I did times 2 and then minus 8. When we're solving, we kind of do it in the opposite order. It's not always addition first necessarily, but it's in the opposite order of how we would simplify if we had substituted in a number, right? So in this case, it is following the order of operations. We would do multiplication first, then subtraction. So that means we're going to get rid of subtracting by 8 first by adding 8 to both sides of the equation. So this is typically the way that's taught. You kind of undo them from the outside in to get to the variable. So we end up here with 2x is equal to 22. Bring in my equal sign directly down. To undo multiplication by 2, I'm going to divide both sides by 2. 2 divided by 2 is 1x. 22 divided by 2 is 11. Now let's check our solution. This is something that we can do. I can come down here and I can plug 11 into my original equation. Turns out 10 was pretty close. We can check and verify. We're asking the question, is 2 times 11 minus 8 equal to 14? Or is 22 minus 8 equal to 14? Yes, it is. So that means our number 11 is a solution. Now, how can we get 11 another way? Well, it turns out the two operations we did were we added 8, we divided by 2. Sometimes you can do them in the reverse order, and I like to think about it this way. It's, I think, a little easier sometimes. One thing I can do is I can divide the whole left side by 2 and the whole right side by the 2. The rule is what you do to one side of the equation, you do the other side. Doesn't matter what you do, as long as you do it to the whole each side, right? So if I divide this whole side of the equation by 2, I'm dividing each of these by 2. 2 divided by 2 is 1x minus 4. 14 divided by 2 is 7. Add 4 to both sides. Opposite of subtraction is addition, and you'll get x equals 11. We get the same solution, but we did it in a different order. There isn't always one order that is the only way. There are multiple ways to approach these questions, so I'm going to do them from the multiple ways, so you can choose. Let's see this next one. 7 minus y over 3 equals 13. We're going to do it twice. I'm going to do it the way that you would have probably done it like in middle school first, which would be to take care of this 7. So I'm going to subtract 7 from both sides. And you'll get negative y over 3 is equal to negative 13 minus 7 is negative 20. Okay, now what we're going to do is we have to figure out how to get y by itself. What are we dividing y by? Well, we're dividing it by 3, but, and we want to use the inverse operation to undo division by 3. But the problem is, what do we do with this negative sign? So to solve that problem, you're trying to get it to the 3's to cancel, but we also want to make it positive. So if you're clever and you note that you're supposed to, multiply by negative 3 here, great. Maybe it's harder to see, but one thing you need to know is if you're doing math and I say, hey, negative 10 divided by 2, that really means it's the same as negative 10 over 2, but it's also the same as 10 over negative 2. All of these mean negative 5. They all mean the same thing. So I'm allowed to take this negative and kind of stick it to the 3 on the bottom. Now it's very clear that if I multiply both sides by negative 3, I'll be in good shape. So that's what I'm going to do. Negative 3 over 1 times y over negative 3. Anything divided by itself is 1, so we're good. And over here we have negative 20 times negative 3. These cancel. You're left with just y. Negative 20 times negative 3 is positive 60. Let's check our solution and make sure it makes sense. 7 minus negative 60 divided by 3, or sorry, positive 60. What am I saying? Positive 60 divided by 3, is that equal to negative 13? Let's check. 60 divided by 3, 60 divided by 3 is 20, 7 minus 20 equal to negative 13. Check. Okay. Let's do this one a different way. Another way to handle these problems, so I multiplied by 3 or negative 3, whatever you choose. If I were to have multiplied by negative 3 on this one from the very beginning, you just have to distribute to each term on the left and then multiply on the right. So let's do that. Let's go times negative 3 here, and let's do negative 3 times over here. Now the reason I want to choose 3 and or negative 3 and not 3 is that negative times a negative will make this term positive. Okay, negative 3 times 7 is negative 21. Negative 3 is going to cancel with the negative 3 here and make this term positive, which will make that plus y. And then over here, you're going to have positive 39 because a negative times a negative is a positive. Add 21 to both sides. Guess what? You still get y equals 60. There's more than one way to look at these problems. Let's keep moving. Okay, how do you justify your answer? Or how do you, be sure that your answer is correct? Well, we now have two options. You can substitute into the original equation and make sure it's true, right? Or you can solve the equation in a different way. So think about it, and if you do it, 2 ways, check with a partner too. That will kind of help you convince yourself that your answer is correct. All right, you guys try this one on your own, and then I'm going to go through and do it 2 ways. Okay, we're back. Here we go. Solving for x, I'm going to add 10 to both sides. This is kind of the way that most people have probably done it. 49 is equal to negative x. I want to get x by itself. Currently, there is a negative 1 out front, so I am going to divide both sides by negative 1. Negative 1's cancel, and you end up with x equals negative 49. Super. Okay, over here, what if I did this in reverse? What if I multiplied by negative 1 first, or divided? Let's divide by negative 1, because that's what we did before. Doesn't actually matter. You'll get the same numbers. Divide by negative 1. Negative 39 divided by negative 1 is, 39 divided by negative 1 is negative 39. Negative 1 divided by negative 1 is 1x, and negative 10 divided by negative 1 is plus 10. Subtracting 10 from each side, and you'll get negative 49 equals x, and both of those can be rewritten as x equals negative 49. Super. Let's look at some fractions. Okay, I know you guys don't like fractions. The way that you would do this to solve would be to add 1/4 to both sides. And this is brutal because now we got to find a common denominator, but we're going to do it this way anyways because we need to practice. 3/8 plus 1/4 is the same as saying 3/8. You know what? I'm just going to, 3/8 plus 1/4 is the same as saying 3/8 plus 1/4 is equal to 2/8, which means this is, so the LCM of 4 and 8 here, right? Then we can add these two together and you'll get 5/8. And now we're multiplying x by 1/2. To turn that into 1, we could either multiply by 2 or divide by 1/2. They're logically equivalent. So I'm going to multiply both of these by 2. 2 over 1 times 1 over 2. X equals 5 over 8 times 2 over 1. Multiply both sides by 2. 2's cancel. We end up with just x. And then over here is 10 over 8. But 10 over 8 can be simplified to 5 over 4. Now I'm going to show you another technique. Another technique when you have a bunch of fractions as a problem, in the problem, is to make sure there are no variables in the denominator, but go through and find the LCM. So you really just multiply the whole equation by the LCM of the denominators. And least common multiple. So I go through 2, 4, 8, 4, 8, 2, 4, 6, 8. 8 is the first number that is in all three lists, which means 8 is what I'm going to multiply both sides of the equation by. Now 8's going to cancel with all of these, or simplify. So multiply by 8 over here and over here. Half of 8 is 4. A quarter of 8, or 8 divided by 4, is equal to 2. Keep the minus sign. 8 divided by 8 is 1, so that's just a 3. And now we just have a regular old two-step equation to solve. Plus 2 plus 2, 4x equals 5. Divide by 4, x equals 5 over 4. I'll let you decide which way is easier, but if you can pick this up in your head and find an LCM or find a number that's going to cancel with all these, by golly, that can really simplify things. Okay, last type here. There are several ways to solve this question. I'm just going to do it once. But the whole idea here, it goes back to that order of operations, right? If I plug in a number, the first thing that I do is I subtract 7, okay? So if I plug in the number 10, for example, I would do 10 minus 7, then divide by 3. So to solve, we did subtraction first, then division. We're going to undo those in reverse order. So I'm going to take care of the division first. So I'm going to multiply both sides. 3 times 12. Then over here, I'm going to do x minus 7 over 3 times 3 over 1. I put it as a fraction because we're dealing with a fraction. 3's cancel, right? If I say, ignore that for a sec. If I say 5 times 3 divided by 3, we just end up with 5. So x minus 7 divided by 3 times 3 is just x minus 7. A common mistake here is that people will end up writing it as this. Negative 36 equals 3x minus 21. Careful there because that 3 canceled. You don't distribute, okay? So then over here we have negative 36, and I can add 7 to get negative 29. And x equals negative 29. It doesn't matter which side of the equation that it's on, okay? Negative 29 minus 7 is negative 36 divided by 3 gives us negative 12. Well, ladies and gentlemen, that's it for this video. Thanks for tuning in. I got to get a hold of Johann Sebastian Jorgensen, so been just swamped. But we'll see you next time.